In this lesson, we will learn about Maya's point constraint. A point constraint is used to lock down an object's position to be controlled by another object's position. This is a very commonly used rigging tool for rigging arms and, in our case, a leg. So we'll take a look at very shortly, but we can also use it as an animation tool. And if you'd like to learn more about how that is possible, feel free to take a look at our animating props tutorial. And we also have a bit of information on it in our parent constraint lesson. But let's go ahead and get right to work applying this point constraint and understanding why we'd want to use it in the first place. So you can see in this scene we have a basic leg rig, and if we were to grab the object RP leg, you can see that we have inverse kinematics applied to this proxy leg. Okay, now as of right now, in order to animate inverse kinematics on this leg, we'd need to grab our IK handle and animate its position. But right now, the IK handle is not ready for animation simply because you can see how its translate channels are not zeroed out. This makes it very difficult for the animator or anyone using the rig to go back to the leg's bind pose, this default position we see. So ideally what we'd want to do is be able to zero out our translate channels and go back to the bind pose that way. But you can see by zeroing out these channels, that's going to bring the IK handle back to the root of the scene, the scene's origin. Again, it's not ideal for animation. So commonly you'll find that there are animation controls built in order to prevent problems like that, in order to bring our character back to its bind pose with ease. So let's go ahead and apply a point constraint so we can still have control over our IK handle while animating on a very clean control. So it's just a matter of grabbing our target object, which in our case is this leg control, and then at that point we'd want to grab the constraint object, the object that should be locked down, which in our case is our IK handle. Now at this point we could head over to our animation module and under the constraint menu choose the point constraint. Let's go ahead and head over to our options and make sure they're set to default, and we'll just go ahead and work with the default settings first. Let's go ahead and choose add. Alright, so you could see that on our IK handle its translate channels have been locked down. And we know that it's by constraint because the channels have been highlighted light blue. Also, if we were to scroll down on this constraint object, you'll see that a point constraint node has been added, where we can do things like offset the position of the constraint object or turn off its weight. So this is why a constraint is so useful, because we can come in here and remove the weight temporarily and animate that change. So notice if I bring the leg control up and over, go back to the IK handle and go ahead and turn on its weight, yes, the leg is going to kind of pop back. And then if we want to remove that offset, we just need to remove any offset values we've added. But now you can see that we have control over whether the target object will have control over the constraint object or whether it will not. This is a great tool to use for dynamic parent switches. If you'd like to learn more about that, we have our animating with props course that covers how to set those type of systems up. But what I'll now do is go ahead and take the leg control weight, set that back to 1, so the leg control will have full control over this leg rig. Now we can grab the control object and go ahead and zero out our translate channels to bring the leg back to its bind pose. Okay, so now that we understand how the point constraint works, let's go ahead and take a look at a few other options we have. So we have taken a look at our offset channels, but we can also create a separation between the constraint object and the target object. To show you how that works, let's go ahead and remove the point constraint. We can go ahead and expand our constraint object to get to its point constraint And now we can go in and delete that. All right, so now notice there is no more point constraint on our IK handle. That's one way of removing a constraint. We also have another tutorial dedicated to removing constraints another way. So let's say we create an offset between the constraint, just so we can learn how this setting works. I'm going to go ahead and grab our IK handle and just kind of move that over to the side. And now, again, just as we've done before, we'll grab our target object and then the constrained object, which is our IK handle. Let's control click that. We'll turn on maintain offset and choose add. All right, so you can see now the constraint has been applied, but there's space between the constraint object and the target. So that's what maintain offset does. It's going to keep the location of the constraint object, but still make sure that it's going to be locked down to whatever we set as our target object. If we were to take a look at our IK handle, scroll down, you can see we can grab the values now of the offset and start to tweak these values. And yes, these can be animated, which is really exciting stuff. You can get into some very creative control rigs this way. Now, if we don't want any offset at all, well, we could always zero these parameters out. And now no longer is there any change in the distance between the target object and the object that is constrained. So that's basically how that works. But if we were to go ahead and undo that back again to before the constraint was made, I'll now grab the animation control, grab the IK handle, and go ahead and apply the constraint again without maintain offset, and you'll see that the position of the IK handle pops back to its parent object, which is our leg control. So you can think of it like parenting, but in a way that is not necessarily fully controlling the object's transforms. And what's also exciting is that we can turn that weight on and off, which is an advantage that constraints have over parenting. The next choice we have is the ability to create constraints on animation layers. We have another tutorial dedicated to this system, so feel free to take a look at that. But another very helpful feature which gives us good control over animating weight changes between the constraint object and whatever target objects we have defined. And then in this second section, what we see is the ability to set what axis we would like to constrain. So here, let's go ahead and take a look at an example of this. I'll just close out the outliner. Let's go ahead and turn on the switch layer. See, we have another basic rig in the scene. Now let's see if we needed to control this switch, which right now drives these doors. All right, so as we pull back this switch, again, the doors will open. It's just a basic set-driven key rig. But let's say if we wanted an animation control over this switch. That way, if we wanted to, we can change this animation control without necessarily having to alter the switch, which is another very common practice. But let's say if we just wanted to control the Z-axis of our switch, which would be ideal in this case, because you could see due to these grooves, this switch should not move in any other axis but the Z. So it's just a matter of, again, grabbing our target object, grabbing the constraint object, which is our switch geometry, and now we'll choose the Z-axis and choose add. So you can see now only the Z-axis has been locked down. If we were to grab our locator and start to move in the X-axis, we'll get nothing at all, nor the Y-axis. However, if we start to now pull this back in the Z-axis, we have control over this object's position. Now you can see that the control object is able to move anywhere we'd like. However, the switch has a threshold. It eventually stops. So what this means is that if we set up any limitations on our controls, we'll take a look at that. If we go into our attribute editor, go to our transform tab and set up any limits, the constraint will stop at the limit we define. So in this case, the minimum that this switch object can move is 0. It won't go any lower than that. It cannot go in the negative direction. The max that this can go is 70 units. So again, that's another very useful tool, in that we can set up limits on our objects to kind of regulate when the constraint should be active and when it should no longer control the constrained object. But that's a look at working with a point constraint. Again, it's used to lock down the position of an object to control another object's position. If we were to go back to our point constraint menu, we've already taken a look at the last setting here, which is our weight value, which controls whether or not the constraint object will be controlled by its target.